homework. So any questions?
Yeah. So has anyone taken the time to actually go through the homework or has tried to get it started? Sort of? Yeah. Have you had any issues downloading things? Or?
Well, not downloading, but of the first moment, I can ask right now. Or we wait?
Yeah, I'll go through it, and if there's an issue, okay. So I'll first maybe try to show where this assignment came from, the inspiration. We're actually, I just decided
Do you
to.
prefer lights on or off? Okay.
Yeah. So we had a cyber physical capture the flag tournament at Rutgers, and this was, I think we had around 40 students participate. So capture the flag is common structure for a lot of security competitions where you try, classical capture the flag tournaments. Usually you're trying to log into a server and you try to hack some component of it. But in this case, we wanted to bring about some concepts about cybersecurity in the context of cyber physical systems. So we had this capture the drone setup where we had this whole arena and we had all these little crazy flies. And the goal was that there were actually, probably barely see them, each team had a zone and the goal was to capture as many drones as you could and have it, at the end of the day, you're trying to hack the air traffic controller and then trying to steal other people's drones. So it was a similar web interface, and we just provided a tracking interface for them. And whenever you requested, where your package was, it would give you some. At this point, we hadn't implemented the localization system, but there was some physical actuation with the drones that were in play. So we wanted to provide a more portable and flexible environment for this, especially for schools or programs that can't afford to set up such an elaborate system. So we started working with this gazebo, which is a simulation environment for the cyber physical systems. And here, this is actually a very slowed down version of the drone flying from between 4 waypoints. And this is actually going to be the system that we're going to be working with. And it's in our scenario, if you guys have read the assignment, it's actually a drone that's delivering packages for different locations. And in our scenario, you can imagine that we're sitting on top of the building in the middle, and that we're trying to intercept the drone and any packages that it's holding onto. So I'll just end the show, and then I'll just jump into the assignment. So I'll just try to walk through this and see if there's any immediate questions that you guys might have. So this is a team assignment. So has everyone chosen your teams? Are you going to be working with your groups, I'm assuming? Okay, so it is team assignment, and as I mentioned, it is based on the lecture that I previously recorded in lecture 10. And there is a supplementary lecture that you guys should have access to as well. And you guys can go through it, but it's supposed to provide an overview of some reverse engineering techniques that might help out with, coming through this. And I do mention it in the lecture, so I recommend at least going through it. It's a shorter lecture. And you'll be introduced to some tools like IDAPRO, and it'll give you a very, very brief introduction to reverse engineering processes. And so this will be submitted via Gradescope, and I will provide more specific instructions as to how to structure your submissions and for each. Oh, sorry. Let me just, so I will provide instructions on the file structure in your submission. So this just provides a background to the story and Nozama package delivery system. It's very similar to the Amazon name, if you didn't catch on to that. And so for this project, you'll need a few things. You will need to install VirtualBox. Everyone here familiar with VirtualBox or doesn't know what it is? It's okay if you don't. And then once you've installed VirtualBox, you can download the appliance file. It's pretty large. I think it's around 6 or 7 gigs. There is a password, and if you want to run it natively, you can follow these installation instructions. You may run into several bugs during this process, so you could reach out to me if you have any issues. So the running it natively would mean that you would be running it on Linux or Ubuntu, and you would first follow the instructions to install the Gazebo and the associated ROS packages. So you could follow this link, and it will tell you all the instructions, and they have it for different versions of Ubuntu and the different versions of ROS. The difference of ROS and Gazebo, and there are dependencies between depending on what Ubuntu environment you're running. And then once you've installed the craziest workspace, then you would just unzip this files, and there's a bash script called installchanges.sh. So you would just run that bash script, and it should move all the files to the correct folders.
Which version of Gazebo Ubuntu do you recommend if they're doing the native install?
So I just use the version 16, the one that's on. I believe it's 16.04 with ROS Kinetic,
Okay.
and I think that's what's on the VM. But any of them should work fine. Yeah. I mean, I've done both 18.04 and version 16.04. And yeah, it depends on, there's going to be bugs depending on what's installed in your system. I recommend using some virtual environments. And so, I mean, if you do go down this route, we can talk about the issues that might come into play there. Okay, so for the first challenge, it tended to be kind of open-ended, and it's very similar to the previous capture the flag tournament, where we are trying to intercept the drone, but it's a little bit more precise because in this case because we're in a virtualized environment, we know exactly where the drone is, and you'll have very precise localization of the drone. So there will be a way of checking to see whether we actually get it to land on the building. So when you boot up the virtual machine, you'll essentially see, you should open up a terminal, and you'll run this assignment1.sh. So I can actually, this is a freshly installed, I just installed this, I downloaded it and imported the appliance before the class, just to make sure that it was working. And while it's booting up, so you're going to run this assignment1.sh, and when you run it, it should open a few things. So you should see an instance of Gazebo running with the drone, delivering the packages, and then it'll also provide you with the web interface on Chrome. And here you should be able to input any of these tracking numbers that you see here. So you can imagine that there's 4 packages out for delivery from 4 different customers, and they each have their own tracking number. But in this case, it's going to be the same, but these are just different tracking numbers that will work with it. And when you enter this tracking number, it should provide you with the command that was sent to the drone, as well as the localization information. So here, if we...
Is it like FedEx, like we're entering the tracking number, we're getting to the where our packages?
No, you should get exactly the coordinates of the drone. So it's going to be in an XYZ coordinates starting from the origin. So if we run this and we go to assignment1 files, we press bash assignment1.sh, and there are issues. So you'll see the web interface here, and you could explore all the links on here. There are issues. I mean, you'll see that when you're with ROS and Gazebo, there might be some issues when you first start up Gazebo. It might take a little bit to warm up, but yeah, I put those in the hints. It could be a matter of just closing it and reopening it. Sometimes this takes a while. So this is a drone going from to the 4 different points, and from here I can enter this tracking number. So if I copy any of these tracking numbers, hopefully I enabled. All right, I'm gonna have to type it. So it's IJ. I don't know why before this the bidirectional clipboard wasn't working, so I think I have to. I didn't install the VirtualBox guest editions, so that will help with enabling the bidirectional clipboard for from your host machine to your virtual machine. But I don't have time to do that right now, so I'll just type it out. NE582. 852. Okay. So when we submit it, you should be able to see. If I can scroll down. Yeah. So it should give you the current location of the drone. So right now it returned to the origin point. But if you get it in time, you can get it mid-flight. And you can see the control tower authorized takeoff. And this is the commands that are sent. So if I did provide some, for the deliverables for this, you're going to have to come up with a payload to execute the interception. And when I say interception, I mean you're going to find that there's a way where we can exploit a vulnerability in the air traffic controller and force it to land on the building. So I don't want to give too many hints, but you'll find that there is a way to do this. And you're free to explore, any aspect of the components that are running. So you could, yep.
So we're interacting with this drone, like the only method of interaction is that interface.
Yes.
And we have to find this part.
Yes. Yeah. So for this, you'll have to come up with you should in the text document. I'll provide more details on the format of the folders and all that. But you should come up with a text document that will have all your payloads or the series of payloads that you're going to do. And you should have a detailed report to try to summarize, how you think the system works. And
Payload is the encryption.
yes, yeah, well, yes. If you read the lectures, you'll see, yes, a payload is the encryption. So, and you should enumerate any techniques that you tried during your debugging process and how you analyze the system. And any code, resources, or references that you use in the attack should be included in your report. So there are multiple ways of implementing this attack. Some are more complicated than others. And one thing you'll find, the coordinates for the center of the building's roof surface are roughly, it's at the -2, 2.0, and z is equal to 1.0 coordinate. So that's like the roof. So yeah, you may need to start up Gazebo, as I mentioned. Sometimes the web page might not be running. You might get a 404 error or something like that. You could restart there's a script in there to restart the website. You could also just look at the assignment1.sh file and see what are all the commands that are being run and decompose it. And yeah, I sometimes, ROS and Gazebo do get a little bit noisy when you're running from command line. So if you find things are behaving non-deterministically, then you might just want to restart the terminal, and in the worst case, restart the VM in case there's some loose processes that are running. So everyone's clear about challenge 1? Yeah.
When is the moment where we should exactly attack the drone? Because when you start the simulation, like it makes like a trajectory.
Yes.
And it waits then forever.
Mm-hmm.
So should we attack when it finishes on the trajectory or in mid-flight or?
So I mean, I left that kind of open. In the real world setting, it'd be nicer to, do it as early as possible because you want to get all the packages before they're delivered. So if this was in a competition setting, I would say, it'd be kind of a metric to say before it reaches each waypoint, you want to, intercept it. But if it's I'll if you have more questions, and once you get to that point, we could.
What all can students examine besides the output and the
So they should. I mean, so you can examine anything on the machine. Anything's up for grabs. So if you want to explore even how the ROS environment works, the network communication, even the web controller, you won't have access to the source code of the of the web server, but there is a binary file that you can access and analyze according to the techniques provided, or that I went over. So anything's up for grabs on the machine. Yeah.
Since the handbook member in the solution is how to create kind of a path scale,
Well, it will be graded based on if you can land the drone on the building. Yeah. But your payload should only be through the web interface. I should say that. So you can only all your payloads should only be through the web interface.
So you can examine anything in the virtual machine.
Yes.
But the tag should only be through it.
Yeah. And the second challenge is going to be slightly different. So now, assuming you've intercepted the drone, I kind of talked about the story here, and I don't want to mess it up, but you found that you did some binary firmware analysis using some hardware techniques, and you found that there's a firmware updater on the drone, and you're able to extract that binary. So in this, I'll probably just close out. Let me just kill all this. So if you go to assignment 2 files, you should see a number of files. And I did provide a way to test it. Whoa, okay, let me just kill this because I think I launched it in the background. Yeah, okay. I think kill all last launch. Okay. Let me see. Okay. So here we have a number of binary files, and I've put the description of each one. But the goal is to essentially implement a backdoor mechanism in the drone's controller's firmware. So in this case, the web interface isn't going to be running because their web services are down and you can no longer track. But we do have access to update the firmware of these drones. But there is an integrity checker that makes sure that any firmware that's uploaded or attempting to be uploaded to the drone is checked against this using this mechanism, this firmware updater file. So your goal will be to create this backdoor that essentially navigates the interception point to the building that you're on again. But it will be trickier this time. So I've set some constraints in here. So because they're wary now that you're trying to intercept the drone, I want to make sure that we only can intercept the drone after we've reached a certain distance from the starting point, because we don't want it to fly directly to the building. So we wanted to make sure that as long as the x is less than -1.0, and y is greater than 1.0, and z is greater than 0.5, these are in meters, I think. We want to make sure that only once we've satisfied these parameters in the waypoints, then we can intercept the drone. So there are multiple steps to this. It will require, you will have access to the source code for the drone firmware, and it will require modifying it so that, once we reach that point, we change the set point for the drone. And then the second part of this will be to actually make sure that once you compile the binary, it can pass the firmware validation check. And you have access to the firmware updater file, but you won't be able to modify it on the drone. So we can't change the way the firmware update mechanism works. We have to we can only modify the binary that we're sending to the drone. Is that clear? So I did have a few files in here. So this lead position controller node.cpp, this is the kind of this is the code that the drone's controller firmware is based on. And you could see the source code here from this. This is from an original GitHub repo. So you'll be modifying this and then compiling it, and then modifying it so that it can be loaded onto the firmware. This generate binary file, it's a script that generates the associated binary file that you'll try to load onto the drone. So it'll create this lead position controller node.cpp.o, and it will load it in the appropriate directory for when you rebuild the ROS environment. This test firmware.sh will essentially it will run the firmware updater.o file to test if it's a valid firmware update, and if it succeeds, it will load it onto the simulator. And you could run this file directly. So here it should be so the firmware updater.o. You could run it. So you need a file name. So one of the files that I'm including here is this lead position controller node.cpp.o.save. This is the original file that was loaded onto the drone when you intercepted it. So this is the firmware update that was valid and passed the firmware checker. And you could see that if you go here, .o.save, you see that it actually passes the firmware check. So you'll find that off the shelf, if you compile, so let's say I have this lead position controller unmodified. This is like the original source code, and I say, okay, generate dash generate file .sh. So now it's just generating this new. Well, it's just essentially taking the modified file, or here it's unmodified, but it's then loading it into the catkin workspace, and then it's going to build it, and then you should see it now in your folder here. So this is the one that was just generated. And now if I run the firmware updater, then I'll say, okay, lead position controller .o cpp.o. So it actually will show invalid firmware update. So you see, even with the original source code, I generated a new firmware update, but some other things were needed to be done to the binary file. So does that make sense? Okay. Yeah. So there are tools. There are tools that I mentioned in my other lecture that you can use to both analyze the binary and also to modify the binary as well. I think I listed them here. Actually, you can see in Windows there's HXD that allows you to analyze binary files, and you could actually change the bytes of them individually. VBinDiff, it's a visual binary diff on Linux systems that you can install, and you could open any binary file and look at the bytes. I think the lecture I gave was on IDAPRO, and BinDiff is a plugin that you could use. So these are just some tools that you can use for analyzing binary files and modifying them. And I think this is another generous hint, but this attack is based on an actual firmware update mechanism attack that was implemented by Air Force back in 2013, I believe. So you could refer to section 4.1.4 of this thesis you could just go to the PDF and navigate to section 4.1.4, and you'll see how they implemented their attack. It should give you some insights into how it's done. But again, here you'll want to be sure to look at because you want to try to figure out how the firmware updater files works, you want to look at the static binary analysis techniques that were presented in the auxiliary lecture that I provided. And yeah, so another point I mentioned here was that, to actually implement the backdoor, you're going to have to familiarize yourself with some of the data structures. So I did provide some sample code here. So there's a function that takes in set points called this multi-degrees of freedom joint trajectory callback function. And you'll create what's called the multi-degrees of freedom trajectory message structure. That's essentially what's sent to the drone in the ROS environment. And you could see the structure from this. This is the data structure of how it looks, and you can navigate these structures accordingly if you want to see how they're made. But I simplified it a little bit because there's a nice little function that allows you to generate these messages from a position and yaw structure. And I showed how you can make this. So for example, if you have a desired position, and here I put x is equal to negative 1.3, y is equal to 1.3, and z is equal to 1.0, and I create some yaw here. Yaw is just going to be 0.0. Roll pitch yaw. I'm sure you guys are familiar with that in some instances, but yeah, here we just want the desired frame of the drum. We just want it to be flat, so we put 0.0 for the desired yaw, and we just care about setting the position. And then you could just declare your message here, and then you could generate this new message using the desired position and the desired yaw. So is that everything clear for challenge? I know that some of these things you'll have to actually play around with. I'm sure there'll be more questions when you actually get your hands in the code. But yeah.
Is there a way to bypass the checkers so we can kind of see what our hijacked firmware, what our firmware would look like in the system?
Yeah, so you could, I could add instructions on that. You could essentially you're gonna have the development workspace for the Craziest, so you could look at where I could point. I'll add a note here, but you could look at it just without the firmware update. You could actually, if you want, you could take a look at. So if you look at test firmware update, actually I think I used gedit here. You can see there's all it's doing is essentially, well, I think it's it's copying the. Hold on, this might not be the file. I think your first. I should be looking at the generation of the binary file, and you can see here there's like directories in the catkin workspace where the original source code could be, and then you would just run catkin build. This will this just builds the workspace, and then you could run some of the you could run this ROS launch Rotor's Gazebo with Mav with Waypoint Launcher. So you could look at some of these scripts and they should tell you, but I'll add more explicit instructions on how to test that. It's a good point. Okay, any other questions about challenge 2? All right. So for the third challenge, this is a little bit more open-ended. So in this challenge, you've been hired by the company now that they've found you and arrested you, and trying to turn you to be the expert on drone security. So now your goal is to implement a new firmware update mechanism, and this is going to be a bit more open-ended in the sense that you want to provide some form of integrity and authentication checking. So you could refer back to some of the techniques provided in, I believe, the Intro to Crypto lecture, and use some of the concepts there.
So, do you have suggestion for any library they can use for
Yeah, I could.
support?
Okay, yeah, I could. Yeah, I'll add some references to this.
Yeah,
actually.
maybe give a few so that.
Yeah. Okay. Sure. Yeah, I'll. So it is open ended. I don't want you to be tied into a certain mechanism.
So basically for part 3, the idea is to make the integrity checker more robust.
Yes. Yeah.
Right? Because in
with
part 2 you're
cryptographic.
bypassing it, and part 3 we want to make sure you
Yes.
cannot bypass it.
Yep. Okay. So any questions? Yep.
You mentioned a roughly one-page report. Does that include the figures?
Yes. Yeah.
Oh, okay, so it's pretty brief report if you have figures.
Yeah. If you I mean, you'll probably have figures. You might have and it shouldn't include the code and all. I expect the code to be in separate files. I'll be more explicit about the structure of submission and all that. But you should be able to sufficiently, describe your approaches and justify why you took certain. You should be thorough. Yeah. Okay. Cool.
Oh, I have one
Great.
last question.
Oh yeah, sure.
About the original competition you mentioned, did teams actually succeed? And
Yeah. We actually had and then I think the prize was actually a drone from some company else sponsoring us. So
we won't get a drone.
no.
Actually,
But
we'll be your own.
yeah.
I have